Hey everyone, so today we will be going over Rhino.Inside. It is a new component, a plugin for Revit that integrates Rhino and Grasshopper inside Revit pretty seamlessly. We went over a little bit in class. I just kind of showed you the basic overview, but today we'll be going over some more in-depth basics, how to actually implement Rhino geometry into Revit, Revit geometry back into Rhino, and some of the basic toolbars that are specifically in the Rhino.Inside environment. So let's open up our template, and please make sure that when you are opening up the templates that you hit new and not open. I know some people are still accidentally doing that. We want to make sure that we're not opening the template file or the .rte file, but actually creating a new project file. All right. So I will just open up the 3D view, and then under add-ins, you have this new Rhinoceros tab, and it says WIP, work in progress. Click that, and it will open up the Rhino Inside tab, essentially. Give it a second. And that's going to give you the options to open Rhino, Grasshopper, Python. There's a Python editor if you're familiar with it, and can write Python scripts for Grasshopper. And then we have a couple different previews. So if you don't want to see a preview in your Revit environment, you just hit off. If you want it to be wireframe there or shaded like you traditionally would see in the Rhino environment, you'll see here. And then recompute is a just in case you want to rerun the script and update the live models within your Revit environment. You hit that, and we'll do that a little bit in the tutorial. And then player is actually if you have a preloaded, pre-done script that you just want to kind of open up immediately and have run in your Revit environment just once. That's where you can do that. So it won't open up the Grasshopper environment, but it'll basically just open your script, run it once. All the geometry or anything that's created in the Grasshopper script will populate in the Revit environment, and then it will close. So first off, let's open up the Rhino environment. All right, and I'll split screen it. And this is the one kind of major issue right now with it still being in beta, is that it doesn't stay open. Once you click the Revit window, it closes the Rhino work in progress program, piece of software. Same with Grasshopper, so just it's a little bit frustrating, but you get to work around it. For today, I will be doing both at the same time. But once you get familiar with the Grasshopper environment and the Rhino, how the Revit environment and the Grasshopper environment intermix, I would suggest writing all your scripts in outside of the Revit environment, just so it's a little bit easier. Actually, I'm not sure if I'll check that out. I'm not sure if the Revit plugin that's in the Grasshopper script that you'll see is transferable, but either way. So right now we'll just be going over how to integrate different geometry, real basic geometry from Rhino into the Revit environment. So we'll just do a point. We can do a complex curve. And then we can also do, let's do something a little, let's do an ellipse. Okay, turn that on ghosted. All right, so right now we have a point, a curve, and a solid geometry. And so to get this geometry into the Revit environment, we have to open up Grasshopper. And to do that, we can either go back to the Revit environment and click this Grasshopper button right here, or we can actually just type in Grasshopper in the Rhino environment and it will open up. And I'll somewhat minimize this guy down. I can grab it. There we go. Okay, so everything is pretty much the same. All your plugins are going to come in that you've downloaded, your Kangaroo, Lunchbox, anything like that. The biggest difference is this Revit toolbar. So the Revit toolbar has all of your any kind of plugin or tool, not plugin, any tool, any tab that integrates and talks specifically to Revit. And these are constantly getting updated, and how to use them is getting updated on the McNeil website under Rhino.Inside. So the first thing that we will do is, just like in a regular Dino or a Grasshopper script, we'll bring in a point. And to grab that point in the Rhino environment, right click, set one point, click that guy, it gets populated in. And I actually have a new plugin that will help you guys, hopefully. This new plugin actually, it gives you a little bubble above that says exactly what those tools are, so I don't need to draw full names anymore. And then curve, same thing, set one curve. And then brep, or our solid geometry in Grasshopper, set one brep. Okay, so now that we have these guys associated in Grasshopper, they actually start to populate in the Revit environment. Let me hide the levels for right now. The only thing that you don't see right now is the point, because it doesn't register in Revit yet. But it will once we plug it into and actually make it a direct shape. So let's open up that Grasshopper tool again using this button up here at the top. Opens up our window, and then all we have to do is, there's several different add components, and it's add, direct, shape, and then by point, by curve, and by brep. So we'll get one of each of those. Let me just show you where. So it's under geometry, add direct by brep, place that down here, and then add direct by curve. And of course you can do by mesh as well. So if we plug these guys in, what will happen now is, instead of just being a preview, we actually get geometry within the Revit environment. So we can actually select them, and this pin is essentially saying that it is live updating. So anywhere we move, if we open up the Grasshopper, the Rhino environment again, and we move the sphere, it moves in Revit. If we edit this curve, it edits in Revit. And what happens if you unpin this is it loses its live connection. So if you move this over here, the geometry itself will move, but the geometry in Rhino obviously will not. And so it actually, let's see, if I update this, the one cool thing is it has somewhat of a response back to Rhino, where it shows where the created geometry moved in the Revit space. So that's the Revit geometry, and this is our Rhino geometry. Now, to get it back, if we click the ellipse and we click that pin back in, and then we go into our Rhino toolbar and hit recompute, it goes back and live edits back to its original place. Okay, so that's a really easy way to get just simple Rhino geometry into your Revit environment. So this is if in case you have some interesting geometry that you just can't really model in Revit, really complex geometries, curvatures, that kind of stuff, you can import it here. Now, the issue is you can use it as a baseline. So let's just take a wall, for instance. It will snap to the endpoints. It'll snap to the point, and obviously it will snap to any kind of geometry on the very interesting. But it can't be used. These are just basically generic models, so they don't really have any material, and especially with the points, they don't really have any what's it called? They don't really have any I can't think of a word, but they can be implemented, especially if you have a 2D drawing that you want to implement into your Revit. You can import that curvature, and it will translate into the Revit environment. But it's not coming in as a, let's say, a true Revit element, right? So it's not coming in as a wall. It's not coming in as a floor. It's just a basic solid geometry. So there is ways to create Revit elements from Rhino geometry, and a lot of them rely solely on curvature lines. So if we go in and we delete these, and we go back into our Rhino environment, and we delete this stuff. So now I'm gonna create all of my geometry in Grasshopper, so it's fully parametric. So I'm gonna go in and delete those. And what I want to do, so first I'll just show you the basic line component. So if we do a line, let's do a line SDL. Start is at, let's just do a point real quick and set one point and just click into the Rhino geometry, excuse me. So that'll be our base point. And then direction, yep, line. All right, so let's make this 100. And we want this to be, so we'll be creating a wall from this line. And one thing to remember with wall geometry, and in a lot of the geometry that we'll be creating in Revit, it relies on horizontal members. So the lines that you create must be horizontal, fully horizontal. They can't be undulating in the Z direction. So let's change this to the x-axis. Actually, sorry, this needs to be, no, I think it can be x. Okay, so now we have, if we move this over, we have a line right there in our Revit environment. And now under the Build tab on the far left of the Revit plugin, there are these add wall, add floors, add different Revit elements by curve, by outline, by location, etc. So we'll just do the add wall by curve for right now. And I'm going to display, sorry. There we go. So it asks for a curve, and then it asks for a couple different parameters that you can manipulate and edit. So if we just plug this line in, now it's creating an actual Revit wall in the Revit environment, and we can start to manipulate the different parameters. So if we do a categories, model categories picker, so this brings about all of the different categories of elements in Revit. So doors, floors, roofs, columns, ceilings, etc. And it has two different ways that you can actually choose these elements. You can do the drop down like you see here, or you can right click and do a checklist. Of course, with this many elements, the checklist is not really that great, but if you wanted to check more than one, you can do it with the checklist. So I'll do the drop down, and then just scroll down to walls, since we are creating a wall element. And then the other thing we have to do is create an element type by name. Element type by name. And both of those can be, oops, sorry, hit the wrong button. So both of those can be found under input. Okay, element type by name, model categories picker. And the sorry about that. The element type by name, it doesn't have an input tab on the back, but it does allow a wire to be plugged in. So if we take our walls and we plug it in to the back end, it then brings up all the different types of walls in our Revit project. So let's just say, let's do CMU on metal stud. Okay, so now if we plug this into our type, now that wall that is drawn from our line, which is parametric, is created as a CMU on metal stud, and we can change that if we so choose. We can also plug in levels for it to be associated with. So under that input tab up at the top, document levels picker. So this brings in all the different levels that are in the project and allows you to plug that in. So right now it's on level 1, but if we switch to level 2, drops up 2, roof, etc. And we could potentially, let me check this out. So if we do both, yes. So this is, if you right click, do the checklist, you can check more than one, and that actually starts to create 3 different types of walls. Yeah, and this preview is just saying that highlighted walls overlap. So that means that our heights are larger than the level heights. But let's just keep it to level 1 for right now. And then we can also change the height. So if we just type in a number slider, plug that in. All of the units in Revit are feet, just for your knowledge base. So any type of unit that you plug in here is going to be in feet. So if you want to do inches, you're going to have to do a divide by 12. And then location line flipped allows joins. I'll get into allows joins. The flip doesn't necessarily matter right now, and I can't find location line. Location line references where the placement line is. So right now I believe it's on the center, but in future iterations I'm sure they will have the actual locations plug-in for it. Alright, so that's really basic, but let me show you real quick how to do floors, roofs, and walls parametrically. So this is just doing one line. If we go back, instead of just creating one line, if we go in and alright, so it looks like even if we deleted this, yeah, so it keeps it in Revit, which is interesting. Anyway, delete that wall, and then go in and let's create a rectangle. So rectangle plane is going to be our XY, and we want it, let's do 100 by 100 for right now at least. There we go. It's not updating. Okay, so we have pretty much a, not pretty much, we have 100 by 100 rectangle, and if we plug this into wall by curve, it's actually going to give us an error because the wall by curve cannot take a multi-line polyline or curve. You actually have to go in and explode it into its 4 segments because each wall needs to be created by one specific line. So if we go in explode curve and then take the segments output, plug that in, then we get our 4 walls. And this is where allow joins comes into play. So see how the corners of these walls are not joined, they're kind of butting up against each other and running into each other. The allow joins is asking for a Boolean parameter or a true false parameter. So if we do a Boolean toggle, plug that guy in and then change it to true, now we have nice joined corners. Okay. All right. So that's a really quick way to do walls, but we can also do floors and we can do roofs. So really quickly, I will just show you how to do that. So if we go under the Build tab, add floor by outline. So instead of singular lines, this is actually asking for a closed planar polyline, and it needs to be horizontal. So if we go in, this doesn't ask, but if we take the rectangle, which is a closed planar curve, we plug that into our boundary. Now we get a nice little floor. And we do the same thing that we did. What just happened? Weird. We do the same thing that we did for the wall. So we're going to want to take the model categories picker and the element type by name and copy and paste those down. And instead of walls, we want to go in and select floors. Let's hit floors. Let's create let's do 12-inch. And then plug this into type. What is this error giving me? Highlighted floors overlap. Are there more than one rectangle? No, one rectangle. That's weird. And then level. So just like we did here, take our document level picker, plug that into level, and then we can check. Does this not work the same? Remember that I am also learning this at the same time that you are. So, I wonder why it's not moving it. I'll have to check in on exactly why that is doing that. But anyway, and it doesn't even. All right, so now we have a floor. And we get an error. Let me try and just create one level. Let me recreate this. Remember also that Rhino.Inside is in beta, so it is meant to have issues. Well, it's not meant to have issues, of course, but it's going to have issues. It's going to have bugs in it. It's going to potentially kind of crash on you, maybe. I've found that if I work on it long enough and I go back and forth between Rhino and Grasshopper, this toolbar disappears. You may run into that. If this toolbar does disappear and you only get the little Rhino tab, just close out, save everything, reopen it, and it'll come back. So this is interesting. But anyway, that's how you create a floor. And it is fully parametric with the walls at this point. So if we go back to Grasshopper and we start to play around, this floor one has been giving me issues. Let's create a roof for right now. Take this rectangle, plug it in, and then we actually want it to be on the roof. Well, so an easy way to get this on the roof is if we know our we know our roof height, which is 24. Then all we got to do is move this rectangle up. Oops. Sorry. Move this rectangle up. In the z-axis by 24. And so I'm going to close out of all of this and open it back up and see if that does anything. Save document. Alright, so that worked. All I gotta do, close out, open back up, and it does what you want it to do. So we have roof actually at the roof. And it is parametric to our rectangle. If we manipulate the box, it'll change the roof. We can change the height of the roof. They're number sliders. And I'm sure if we plug the level in, I would do that as well, but I'm not going to try that at the moment. Okay. So I've shown you how to create the geometry in here. Now that obviously this is very simple geometry, but when you're doing some really initial massing, you can utilize these tools to be able to parametrically change, alter, and produce and rapid prototype different layouts and different schemes based on different parameters that you implement. We can also, we'll go over, I'm going to explore a couple different more complex ways to integrate this using some complex geometry that we create in Rhino and then manipulate in Grasshopper to create Revit environment, or excuse me, to create Revit Elements. But for right now, this is just an introduction into how to use some basic elements to create a Revit model. So we can save this and close out. Start a new file. So file, new document. And then we can go in and unpin and delete all of this. So what we're going to do now is the opposite. We're going to take Revit geometry and import it into Rhino. And we can do this already by exporting CAD, but it doesn't come in very organized. It comes in with every different type of AI naming convention. It gets really cumbersome, and it imports everything. And so the way that we're going to set this Grasshopper script up is it's going to be very specific. We can specify each different Revit element that we want to import: floors, walls, roofs, mullions, etc. And import those under specific layers. So we can also do some layer organization before we import the geometry into Rhino. So if we go to our level 1 plan and just create a really basic wall, let's do an ellipse. Might be getting too complicated, but whatever. Feeling ellipses today. Okay, and then let's do a floor. Remember, you can tab through to get a full floor boundary. Let's do a roof, and let's move it to the roof level. Do the same thing, and then for right now, let's just stick with that. So if we go into 3D, let's take these walls and connect them to the roof. So now I got kind of a funky building, ellipse building. And so now to import that stuff into Rhino, we gotta first open Grasshopper. And let me open the bifocals. And then let's open up our model category picker. And let's open the walls. Okay. Then we need a category filter. There it is. Sorry. So plug that category in. And then document elements. All right. So what this essentially has done right now is it's gone into the file and it has selected all of the walls. Then it's gone in, or we've essentially said we want to choose the wall, any wall element. Then it's gone in and filtered all of the elements in the project to just walls. And then this filter actually breaks it down into, if I do a panel real quick to show you, it breaks it down into all of the different elements of that specific category. So it breaks down all of the different walls. So right now, all we have are two walls in here. We have this half and this half. All right, so that's how we isolate different elements. And then if we go in and do element geometry, Alright, so I was kind of right when I said that I probably was getting a little too complex with the ellipse. There we go. Okay, so the ellipse, I don't know why, but it was causing too many issues. So I went back in and rebuilt what we built before. 4 walls, pretty straightforward. 2 floors, one on level 1, one on level 2, and then a roof at the roof level. Okay, and then when it went back into my Grasshopper script, it's all the same, and it still has that geometry. Now that geometry is actually populating. Revit does not like complex curvature, and Rhino.Inside hasn't figured out a way to deal with that yet. I'm sure once they continue to develop this software, it will get better and better. But for right now, let's just do 4 straightforward walls. And what we can do is, now that we have the preview, we can actually, if we open in Rhino, we can see that geometry, and it comes in as, if we open Rhino, once again, it's a little frustrating. Now that's coming in as geometry. And we can bake that geometry, I believe, if we go into Grasshopper and just hit bake. Specify different levels. And now that those geometries come in as poly surfaces. So that's one of the nice things about the interactivity between the Rhino.Inside with Revit and Rhino and Revit in Rhino.Inside is that it comes in as poly surfaces, not meshes, which sometimes happens if you export just a CAD file from Revit. Sorry. All right, so the other thing we can do, so let's do floors real quick. So let's copy and paste all of this down. We can get rid of the panels, and then instead of walls, we can do floors. I know this is riveting stuff. And then let me go in and turn all of this to halftone just really quickly. Maybe see it a little bit better. So now we have two. I don't need to flatten these, sorry. We have two levels, and one thing that we can do with these filters is not only can we filter out the elements from the category, but we can also filter out the levels. So if we get a level picker, document levels picker, level 1, and then a level filter, we just had it, element level filter. Then we can plug those in to, instead of the document elements, we'll plug it into what's called a logical and filter. What this does is it takes two filters and sorts it essentially, and brings up what both filters are calling out. So it's going to take the floors and any floors on level 1 and filter that out, so we can replace this guy in here. Whoops, sorry, still need that one. Filters into one singular filter that then gets plugged in here. Okay, there we go. So if we move this over, and I apologize, but now we have both, or we have level 1, and if we can go in and check level 2, interesting. Learn something every day. Alright, so if you uncheck both levels, it'll bring in both floors, and then you can specify one or the other. For some reason you can't check both. I would assume that you would be able to, but for some reason it's not letting me. So for right now, we'll just do level 1, and then we can do the same thing with roofs. Copy and paste that stuff down, change our model pickers from floors to roofs. I know this is very repetitive, but it is what it is. And then we don't need we only have one roof in the project, so we don't need any level filters. Okay, so now we have all of the different geometry in Rhino. We can delete what we baked out for right now. And so you can bake those in, and you can set up the layers manually, or we can go in and create the layers in Grasshopper. So if we do category identity, and then we do an object bake. So object bake is in Lunchbox. So make sure that you have Lunchbox downloaded. You should have Lunchbox downloaded if you took my class last semester, but if not, it's on that, what's that website? Food for Rhino. Food, the number 4 in Rhino. So we can take the category identity, which plugs in all the different names of the actual category, and plug that into object name, layer. So we plug in the geometry objects to the object bake, and then we can do object or a layer color as well. So if we go into our color wheel or color picker, sorry, I spell it weird. give this an interesting value. Plug that into layer color. And then bake toggle. So we need a it needs a boolean, and so you can do a boolean toggle, which toggles on and off, or you can do button. So what a button does, I don't think we went over this last semester, but a button, just as soon as you click it, it hits true and then it turns off again. Oops. So that's really what we need. We don't need it to continuously be turned on. All we need is it to just bake once. Look at that. So now we have a red layer, and then let's see. Oh wait. Let's try that one more time. So let's plug the name into the layer. Disconnect this guy. There we go. So the name of the category gets plugged into layer, which is essentially layer name. Plugs in right here, and then the color changes. And yeah. So now we have walls, and we can do the same thing with floors. And our roofs. So roofs, let's make, oops, there you go, make blue. We'll need our category identity from each one. Name to layer, name to layer. Purple. All we gotta do, boom, floors, roofs, and now we have geometry to play with in the Rhino environment directly from Revit. One thing I wanted to show you guys that I found out. So in Grasshopper, obviously we have a lot of different wires, and we want different floors. Excuse me, not different floors. We want as much organization within the Grasshopper script as possible. And so one thing we can do if we wanted to drag stuff off is, there we go. You can actually turn, if you right click on the input, you can change the display of the wires. I may have shown you this before, but I refound it out. And if you just click and move it around, you can see where that wire actually goes to. But it helps clean up the model, because I'm sure you've seen significantly complex Grasshopper scripts that get extremely messy extremely quickly. Alright, so that's a really basic overview of how to take Rhino geometry, import it into Revit, and Revit geometry and import it into Rhino. This will be attendance. I'll have a separate video for your assignment. It'll be diving a little bit more into parametric elements within Rhino.Inside corresponding to Revit current panels. And I will upload that as well Thursday. Remember, if you are having issues with the Rhino.Inside, close out, reopen it, and it should reset. It's still beta, but I believe you are going to have significantly less problems with Rhino.Inside than you would with Dynamo. And we'll continue to explore.